VHDL code. For this 4:1 mux with the 4 data inputs and it have a 2 control inputs A and B. Okay, the control inputs select which one of the data input is transmitted to the output. The logic equation for the 4:1 mux is F is equal to A dash B dash I naught, that is 0 0 plus A dash B into I1 0 1 condition plus A B dash I2 1 0 condition plus 1 1, then for I3 for AB or I3 condition. The 4:1 multiplexer, we have a 4 possible condition 0 0 0 1 1 0 1 1. For these, depending upon your select line, then your output should be getting. For this one weight model for the mux is with, can write VHDL statement is, this is normal way you can write F is less than or equal to not of A and not of B and I naught. Okay, this is I am writing for the first condition. A is equal to 0, B is equal to 0. Now my select line is A is equal to 0, B is equal to 0. Then I can't get the output of F is I naught value. What is the value will be stored in I naught? That will be passed on to F. Or then X is equal to 0 and that the second B is equal to 1. Then how to write VHDL code is not of A and B and I1, or A and not of B and I2. This is for A, B dash I2. This is third condition is 1 and 0. And the last condition, A is equal to 1, B is equal to 1. Then I can't write the VHDL code is A and B and what is the data in I3, that is moved on to that line I3. You can write A and B and I3. Okay, this is the normal representation of 4:1 multiplexer. The same program I can also write in still 3 different form. What's the 3 different form? See, you can write the different form of VHDL code using the different statement, conditional statement, signal assignment statement or data flow statement. See, okay, this is the one form I am writing and this is the second form I am writing and the third one below you show the third form writing. Okay, this is the block diagram I am taking. The block diagram shows, the block diagram contain I0, I1, I2, I3, I4 is the data line and the mux is the representation, A and B your data select line and F is your output line. Okay, this is for your third type. Okay, this diagram can represented as, this diagram can be represented as using 3 different forms. And what is that first form? See, let me start for the first form. F is less than or equal to I0 when A and B is equal to 0 0. Else I1 when A and B is equal to 0 1. Third, else I2 when A and B is equal to 1 0. Else I3. Okay, this is the first type. Then how to write the first type? Let I show what is that one. The first type you show the expression A and B means A concatenated with C. See, A ampersand B. If you write A ampersand B, it is called A is concatenated with B. Okay, A is concatenated with B. Then that is 2 bits A and B are merged together to form a 2-bit vector. Together to form a 2-bit vector. Okay. Next, this bit vector is tested and appropriate mux input is selected. For example, see, we can take an example. If A is equal to 1 and B is equal to 0, okay, this condition I can write in the concatenated form is A ampersand B is equal to I0. In this condition, I2 is selected. Okay. Instead of concatenating A and B, you also use the more complex condition. Again, this is the first one. I am using concatenating A and B. Okay, this is also same as this type of problem. Okay. Now the third one is, this is the third one. Instead of doing concatenated, you can also use separately for each bit vector. F is less than or equal to I naught when A is equal to 0 and B is equal to 0. See, A value is different, B values is different. The first condition, both are combined together, I am representing. Else I1 when A is equal to 0 and B is equal to 1. Else I2 when A is equal to 1 and B is equal to 0. Else I3. Okay, this is the second form. What the second form says, see, instead of concatenating A and B, we could also use more complex condition type. This separately I am declaring A and B. Okay, this is the third condition. See, for this you have to write, you should be knowing about what is the syntax. See, that is called the general form of a selected signal with assignment. This is the what? Another type. This is third type. See, okay, first type is over, second type is also over. The next move on to another type is called selected signal assignment stated. Instead of you are writing in the code part A and B or A or B, before that I am declaring what is A and B with a select keyword. I am taking a select, the SEL is less than or equal to A and B. The select can be any variable type declaration as like C. The select is less than or is equal to A and B. If you give the value to A and B that is stored in select, that keyword you can use as with select. With is a keyword, select is also a keyword, and SEL is a variable. Whatever the value you passed into A and B, that is stored in what? Select. According to the value of select, the given function works normally. See now, the SCL is 0, 0, 0. Then F is less than or is equal to I naught when 0, 0. See, here I am not passing any AB because the previously I am declaring what is A and B. Because of that, F is less than or equal to I naught when 0, 0. Next is I1 when 0, 1. I2 when 1, 0. I3 when 1, 1. See, the select value that I am giving different according to the condition that output will be determined, then the corresponding data line will be assigned. See, this is called selected signal assignment statement. What is the syntax for you writing the selected signal? Okay, that is shows in this slide. The syntax, or we call the general form of the selected signal assignment statement, is with expression yes select. See, this is a variable. This variable you can write anything. Okay, there is no restriction to write like this only. Okay, but with and select is a keyword. That keyword should be must and should be there in that program. Okay, then signal S. What is a signal S? Is an output statement. Where to be stored your output? The signal S is less than or equal to expression 1. The expression 1 is your condition of, see, in the program you can use delay or without delay. You can write the program with or without delay, because if you go a delay topic, there are different form of delay should be there. Just I will tell you what are the delays are there, but you can't go in depth about what is the delay, what will we do, all those things is not required now. Then expression 1, when choice is 1, our selection is 0, 0, then expression 1 is executed. Expression is 2, when selection is 0, 1, or expression is 3, the selection is what? 1, 0. Expression is 4, your selection is what? 1, 1. But you have n selection. And with n choice, you can write the general statement as expression n after delay time when others. Okay, this is for other choice. If it is all the choices is over, then the last statement should be executed. Okay, this is a concurrent statement executed whenever a signal changes in any of the expression. The first expression is executed if it is equal to choice 1. The signal S is set to the expression 1. That is for expression value is 0, 0. Then it is equal to the choice 1. Then the signal S will be assigned with what? Expression 1. Or if it is equal to choice 2, the signal S is set equal to the expression 2. Okay, if all possible choice of the value of the expression are given, the last line should be omitted. Same as if any one of the choices is executed, then the default statement is not executed. If the other way, the last statement is required. If no one choice is satisfied, the last statement should be compulsory executed. If it is present, the expression S is not equal to any one of the enumerated choice, the signal S is equal to the expression N. Okay, this is different from how can you write the VHDL code for your multiplexer.